I'm an artist originally from the UK, and I've been living in Toronto for about 4 years. I primarily work with digital media. Particularly, I'm interested in data from science and space exploration. Today, I'm going to talk a bit about my work with data and how I work with this creatively, and split that into 2 sections. The first part of the talk, I'm going to look at kind of past projects and exhibitions and look at how I began to build a creative framework to work with data. The second part of the talk looks at my most recent current works, which focuses on rendering information into physical forms. And I like to, in this, I highlight glitch, error, and computational bias to form a deeper contextualization for how I think about and present information. I'm going to try and keep the talk as visual and interactive as possible, playing sounds and video over a shared screen. Unfortunately, there might be some lag, so I've given Clio links to most of the things that I'll be sharing. I've also uploaded the PDF of the presentation, so we can share that with you if anyone wants to see any of the images or videos in high resolution. So I'm going to go ahead and attempt to share my screen. Okay, so the talk today is going to be split into 2 parts, as I was just saying before. I'm going to start off by talking about my older work in this section called Code Poetry and Electromagnetic Landscapes. So a really ongoing, early and still ongoing exploration for me was working with this area of the radio spectrum called very low frequency. And very low frequency radio is basically ionospheric activity. So the northern lights, lightning, it's basically things produced in the Earth's magnetic field and by the Earth's magnetic field. So around 2013, I started building these big coils of wire essentially to record the electromagnetic spectrum of the Earth, picking up all sorts of things, including the sounds of planets, the northern lights, the sun, radio from Jupiter. So this is a series of ongoing kind of installations, and this is kind of relevant to my work with information now because it really taught me that I was converting what I thought of as sound. I was converting this radio spectrum into sound that I was listening to, and rather than thinking of it as of sound, after a while I kind of thought about it more as these information points that I was converting into sound through amplification devices. But once I began thinking about it as data, I started being able to utilize it in lots of interesting ways. I initially came across very low frequency in a book by Nicholas Collins called Handmade Electronic Music, which is a really great hardware hacking book for building simple hardware synths and things like that. He describes it as fans of what is known as VLF make big coils of wire by wrapping yards of wire around big wooden crosses and then camp out on remote hilltops like hermits. If you get far enough from civilization's ubiquitous 60 to 50 hertz hum, you may be lucky enough to pick up the aurora borealis, whistlers induced by meteorites, self-immolating as they enter the Earth's atmosphere, and the pipping of GPS satellites. So obviously I had to sort of try this, and it really conjured a very evocative image. So the first series of installations that were pairing my interest in sound, which was before was just a creator as a kind of just a music producer with art, were these series of installations called A Machine to Listen to the Sky. And in these installations, I built various VLF antenna and inductors and recorded these sounds and presented them to the public. I was really interested early on in my kind of artistic practice of translating sounds and images that were unexperiencable with our actual inbuilt senses to something we could experience, because they're still around us, they're still present and prevalent. They're just things that we can't access. So for example, like I was equally as interested in technological signals produced by things like electricity pylons, as you can see in this more recent image, as the crackling of lightning and the northern lights. For me, I was very aware just of these kinds of things, because once you listen to, say, a television playing in the electromagnetic spectrum, it's very aggressive and loud. So I kind of had 2 parts of this practice where I'd record natural sounds and I would record sounds which were coming from mechanical signals as well. So I'll play a little bit of a 2015 or 16 documentary I made called Some Call It Noise. And this is an example of some of the natural sounds that are recorded by VLF. It combines a number of experts and artists where I kind of made this stream of consciousness documentary.
Okay, now by about 8 minutes before 6 a.m., 12, coming up on 1300 hours in about 6 or 7 minutes, that's 0600. On 12 April 2011 near Keeler, California, this is Whistler's. Beautiful this morning, early on a Tuesday morning. It's just...
So that was a kind of a maverick, an artist called Stephen McCreevy, who lives in the Californian desert and records natural radio very militantly over the last sort of 30 years. He's really great. And the sounds that you were hearing were lightning getting caught between the Earth and the ionosphere, creating these little tweaked whistles called whistlers. And those kind of sounds really excited me, but there were also all these sounds that I was hearing, which, you know, I couldn't really access 20 miles away from electricity grids, and you actually have to get relatively far away. It's about 2 kilometers to really away from any electrical signals to actually break this down and get natural signals. I was living in the city, I was living in London, so I was hearing things like the electric grid, mobile phones, GPS, Wi-Fi. So I started bringing these devices onto underground trains and really dominantly electromagnetic areas. So this is an example of just some of the sounds that I heard on the London Underground in a 2013 piece called Changing Signals. Hopefully the audio is not too loud. It's weird in kind of changing the audio, in sharing the audio. So I can tweak that up or down if it is too loud or too quiet. It's good? Okay, sweet. So I was really interested in kind of making people aware of these sounds that they're experiencing but not aware of. And this is kind of my early introduction to just kind of thinking about sound as information. So something I've been doing a lot, and the reason I mentioned VLF as a fundamental kind of foundation to my practice, is that over time it did show me that the sounds I was recording and collecting were not sounds, but also data. It was the fluctuating flow of electromagnetic particles flowing through these antennae that I was building, and these fluctuations were being converted into sound. So it's really similar to what's happening now. Like I'm talking into a microphone which is vibrating, and that vibration is being translated over a network, and there may be errors that are introduced by that network, either by the software or by, you know, low latency, or just lots of things between me and you. And that's translating my voice with the errors that are kind of built into it to you, and then vibrating your speaker. So that was kind of the interest I had in translation of data. That was really kind of fundamental to me, I guess. I did a couple of early books about VLF. I used to teach a lot of workshops where people would build antennas and receivers. So I have a document online called VLF, a Sound Artist Guide. If you Google that, you'll find it. I can send links out to people, but basically it introduces what VLF is, some of the sounds that you should expect to hear, some background on radio astronomy, because these devices are basically very low fidelity radio telescopes, and tools of the trade, some reviews of stuff, electronic tools that I have built and share, and also a series of my artistic diaries where I'm going and recording these sounds. So let's get back to this. And these are some of the, if I can share it. Sorry, I'm having some issues with the I'm gonna have to stop the share again, I think, and then restart. Sorry about this. Okay. This might happen a couple of times. Now I think we're back. So these are going through again some of the devices I've been building. I've been working with a magazine called the Site magazine recently, just to do some localized installations. We were due to do something at the Bentway this coming weekend. Obviously it's been rescheduled, but sometime in the fall, we'll be doing a kind of interactive electromagnetic sensing walk with these small devices I've been building, using balloons to kind of elevate antennas and reveal electromagnetic sounds around us. These are sort of broken down versions of this much larger installation that I was performing for a while before. So at the same time as I was working with VLF, I started a code practice. And basically I've been a musician. I've been interested in visual arts. I hadn't done very much visual art before because I'm not particularly strong on my dexterity. I wasn't a great drawer. I wasn't a great painter, but I really liked art and I always was interested in sort of the concepts behind art. So for me, finding kind of generative art and code, I was introduced to this because I was learning digital signal processing as part of my sort of degree. I got into learning how to code, but was much more interested in visuals than sound, because I couldn't make visuals the same way I can make sound. So I started working with generative art in a really big way. And let's just move some stuff around, sorry. Lots of my screen sort of blocked off. So I started this blog when I was starting out, and it's been, I don't really update it anymore, but it's been going for like 7 or 8 years, called Code Poetry. And basically the idea behind Code Poetry at the time was to do these little sketches every day just to keep myself going in computational practice, and just post them online. So it was kind of like a visual diary. And I can then go back and follow these trends of what I was working with. I stopped updating it about 2018. So this is kind of mostly like a couple of years old, but there's a lot of stuff, and there's a nice archive facility of the fact that it's on Tumblr as well, so I can go back, and it's like a repository of all the code I was doing. But yeah, basically I wasn't thinking about the functions and the generative art as information at the time, but once I became friends with some coders and people who are working kind of as engineers, they referred to these random processes I was using as sort of, simple data sets essentially. And that's when I thought, hey, I can actually access some information from organizations such as NASA and start bringing that into my work. Which really led on to my kind of the work that I'm doing now, which is an ongoing project called Turbulent Forms, which combines my code-based work with my sound-based work. And the first iteration of this was performed in Hamilton at the Factory Media Center in 2016. And it was the sort of perfect way of combining everything I was doing. And it also let me create a new work called Helios. And so this is just the heliosphere was a journey basically from the sun to the outer edges of its influence. So it basically kind of just mapped the heliosphere in a number of different ways. I'd never really made an audiovisual piece that actually combined my interest in data in terms of sound and visual. It had always been one or the other. They hadn't been combined. So for me, this was a really important work. Just to have the opportunity to be commissioned to do this work was something that helped me develop a whole new stream of practice. The image here is a still from heliosphere. It was initially it was a sonification of the movements of planetary bodies, their rotations and orbits. And I converted that into an image, and in a conference called Seeing Sound, which was held in Bath, me and an artist called Daniela De Paulis converted that image back into radio waves, and we bounced it off the moon. So this is the received signal of this sonification of all the planetary bodies in our solar system received back. So the glitches are introduced by the process called a moon bounce. In a quite poetic way, everything is kind of going out into space, and the radio signals degrade. But if you have a strong enough receiver, you can essentially recreate a lot of these signals. And a lot of the radio astronomy stuff that I became interested in, and we'll talk about a little bit later, involves kind of using these algorithms to extract information from very noisy data, which is extracted from, you know, planetary bodies and solar systems millions and billions of miles away. So I'm going to try and play a clip of not Heliosphere, but a sort of a subsequent work called Helios in a minute. And basically, the project of Turbulent Forms was, after the Factory Media Center, it was kind of firmed up. And let's see, I've got a PDF of this. It was firmed up. And I was able to do something with Arts Council England funding. I worked with the Canadian Music Centre and New Adventures in Sound Art to produce a show with a number of Canadian artists. And these are some of the examples of the work that was exhibited, which is not coming through very well, but some of the data sets I was working with were gravitational waves. I was working with the cosmic microwave background, and I was also working with, gravitational waves, the cosmic microwave background, and sunspots. I also developed an installation piece called Nova, which was an immersive audiovisual piece that basically mapped all the supernovas that have ever happened and been recorded by humans into this sort of this immersive space. So this is a sort of a monograph that documents a lot of the visual work that was in it. And I will in a minute talk about some of the methodologies I developed, because this was really where I firmed up actually how I was working with data. Before, I was kind of just grabbing things and doing some visualizations and kind of just saying this is data work. And this actually allowed me a lot of time to do research and development and think about the sources I was using, how to turn information into sound in a process called sonification, and also a process called orderfication, which I'll talk about a bit later as well. So I'm going to play a video of the Helios installation, or sorry, the Nova installation. And hopefully you can hear it. So I don't know how clearly the audio and the video are coming through, but essentially this is an installation I made using a bunch of ways of distributing light and sound to map supernovas that have been recorded in human history. So there's one pretty basic kind of visualization which is projected onto the wall with an overhead projector. And that basically maps the supernovas in date. So it goes from the oldest at the top to the youngest at the bottom. So you can see here, if I zoom in, you can see that the frequency of supernovas detected over time becomes a lot higher because astronomers were building these machines that essentially were built to detect supernova activity, and some very, very small or far away supernovas that we wouldn't necessarily have seen. The initial starting points of the data go back almost like 800 years. And these are massive things that could be seen without telescopes from Earth. So I was basically doing a simple translation here of frequency and magnitude into a visual. And then the sound was distributed in a number of ways. So I created basically a generative patch in MaxMSP that took all the information and cross-modulated with itself to make these kinds of modular synthesizer sounding tones. And I was outputting things through the television screen. Basically, when I work with information, I have kind of three ways that I like to think about and work with data. So there's quantitative stuff. So if I can go back to this, there's quantitative stuff. So it's basically direct mappings, almost like a graph, and that maps into the sound as well. So this is a mapping of all the sunspots that at the time had occurred in my life. So a 26-year period at the time in 2017 when I did the second iteration of Turbulent Forms. And so the circles are very simply mapped to, again, the number of sunspots per day and per month. And then you can see clearly this 11-year cycle during my lifetime. And the sound mirrors that. So that's really quantitative. It's an interesting way of working, but really it's not creatively that exciting. So there's other things I like to do that kind of remove things and add a creativity to it. A big part of my practice is not just presenting information, but also asking questions about the narratives that are attached to information. So, you know, like initially when I started getting into astronomy and listening to stuff that was, you know, this is a sound from space, this is the sound of two black holes colliding. It's really built by the media on the surface level. Like these are acoustic sounds, these are physical sounds that you can hear happening. And it takes a little bit of digging because the information that they're kind of using to make these sounds isn't always that available or transparent. So something that's interesting for me is how the information that we kind of experience as a sound or a graph or a visualization is kind of mapped for us by not just by the sound we're hearing, but by the text that we are given alongside it to interpret it in our minds. So I really like to work with this idea of kind of a abstract metaphor as well. So I made a piece as part of the Turbulent Forms exhibition for the second iteration at the Canadian Music Centre, where I mapped the cosmic microwave background and basically related that to this process called generation loss, which is the repeat loss of information in copies of a file. It happens if you scan a document multiple times and then take the output and scan that back, you lose the signal quite quickly. So down here at the bottom, you can just see an example of generation loss over a number of iterations. So 1, 30, 90, just on a cloud. It also often has this process of zooming. So just by kind of repeatedly saving this information, the image becomes zoomed in. So I basically built a script that just saved and saved and saved these images over and over again, creating generation loss in the cosmic microwave background, and then generated sounds and images from that. And for me, that's like an abstract metaphor. It relates to the cosmic microwave background in the same way that the CMB comes from the Big Bang, and it's this kind of immense amount of information and energy that was at one time, and we can still access it and see. Like, for example, we can map it, and there is a detectable amount of radiation, but it's very, very low. So this massive amount of energy has degraded and degraded over time, and so the process of generation loss was meant to be kind of like this analogy of breaking something down and kind of just creating an analogy between the image and the content that was created and the kind of the science behind it. So that's a way I kind of think about working a lot. And then the final way, which kind of manifests in the Nova installation that I played a minute ago, is this kind of collisional aspect of working with data. So the cross-modulated sounds that you're hearing is basically every year I take all the supernovas that occurred and then cross-modulate those together in a modular synthesizer, and that gives this output. And it's not necessarily a useful output. Like, you don't necessarily get any information from it. But the idea is that basically by combining things in very, very massive amounts of information in unexpected ways, you could get a actually coherent output. And that's kind of the question there is, like, if you actually collide things together, could you get something interesting? Or is it actually something that's useful, but just far too complex for our kind of sensory apparatus to understand? So that was kind of what I was thinking about in the Nova piece. And it also incorporated a lot of information that was just very quantitative, like this basic mapping of the supernovas, which you could look at as basically a timeline of all the supernovas that have happened, and you can read it by date going down. So it's the month goes across and the date goes down, and the size of these rectangles essentially is how large these events were. I'm going to play another video. And if anyone wants to take a break before I go into this is the last kind of video I'll play of the first section where I talk about my kind of older work. This is a piece called Helius, which was in a recent exhibition that was last summer, and it kind of built on my original heliospheric installation, and kind of only took heliospheric data information from a certain period. So the other one was basically this mapping of heliosphere. So it's kind of like an imagined journey of the sun's, a particle from the sun heading out into the universe and hitting the edge of the heliosphere. And Helios is really just a kind of a series of sketches around the sun, taking information from a year-long period, and then seeing how many ways I could visualize and sonify these. So in that section of the video, I was going from some of my own sonifications and visualizations into a bunch of stuff that was recorded again with a piece of astronomical viewing software called SAO9, which is used for viewing a whole load of scientific and astronomical information and building scripts to kind of interact with that. Later on in the piece, it's quite a long piece, so I'm just kind of going to skip through some bits. Later on in the piece, I was mapping, again, these sunspots onto a 360 orb. And the end finishes with a much more sort of violent, we'll go back a bit further, a much sort of violent kind of almost zoetropic breaking apart of images of the sun. still laggy, but this is going to be pretty fast. And the end section basically takes all the highest magnitude sunspots from the year and kind of plays them back in very, very, very quick succession. So it creates this kind of flicker effect to the viewer in the space, and it can be quite overwhelming. The full video is up online. I uploaded it last week if anyone wants to check it out. It's on Vimeo under my account, Daniel Tapper. So you can access the whole video there. But at this point, I'm kind of going to move on a little bit to some of my more current work. So this is the section 2 area, and it's called SuperLattice. So the work I've been doing over the last year to 2 years has really been thinking about how do I kind of consolidate some of the work of information I've been doing. How do I create a more in-depth framework for, one, the questions about information I have, how do I present this information, and two, how do I bring in my interest in narrative that is given by a sort of to the reader in association with the data. So this has been sort of my ongoing work, has been working with not just information, but also objects that distort information. So I've been looking a lot at this mineral called optical calcite, and optical calcite, which you can see in the images here and also here. It's a really interesting mineral to me because it has the ability to polarize light. So the really basic description I first found of it, someone gave me, was basically you can create quantumly entangled light particles through optical calcite. So you have, as you can see in this graph, the sort of the unpolarized light that continues through, but then you have an extra ray that bounces through. So you get this doubling effect when you put it over a piece of text or you project something through it. So I was just really interested in the sort of the properties of this object, and my initial kind of goal was to create a computational system to basically mirror what calcite does in a computational sense. So I started thinking about my early questions about audio collection and sonification. So the questions such as like, how was the sound collected? What processes were used to record and present the sound? And how do presentation methods and media dissemination strategies affect the way that listeners hear and interpret the sound? So that goes back really to some of my earlier questions, I think, about media representation and what is provided to understand a sound. So that was kind of what I was playing with in projects like Helius and Helius, but not quite maybe understanding at the time. Maybe it was sort of on the back seat. Let's go down. So this is a kind of an example of one way I actually like to visualize information. So this is, and I'm going to go through a couple of ways of how I convert information into sound. So basically this is a graph from Voyager, from its plasma detectors. So I believe this is the plasma detectors from Voyager 2 during the year 1979. Yeah. And so you have 3 plasma detectors, and basically I've mapped them. So you have each detector separately. So you have detector 1 here, and they're all looking for the same things, just they're at different positions of the spacecraft. You have the second detector here and the third one in green. I've also linked them together so you get a slightly more exciting image. If I go to, I'm going to minimize that. If I go to VLC, I can start playing some of the outputs of these plasma detectors converted into audio in a number of different ways. So there's the first way that I would kind of talk about converting audio or information into sound is orderfication. So orderfication is basically where you take a data set and it has its range of kind of values, right? So you could have, say, the lowest value could be minus 200. It's basically whatever paradigm that detector has that's recording and how they're taking that information and putting it into a spreadsheet. So basically, I think for the Voyager plasma detectors, the lowest data point was sort of like minus 79. The highest was like 289. So basically you take the lowest and the highest point and you map those between the scale of audio rate. So basically every data point becomes a sample in sound. So basically you're taking a data point and converting it into audio range, and it's one sample. 1 second of sound has 44,100 samples. So you need a lot of data to make anything really happen. So it also sounds often quite glitchy and quite not, quite hard on the ears. So this is just the raw orderfication of a basically one-to-one mapping of information into sound of the same visualization you saw a second ago. And that was a calcite crystal under a microscope. Okay, so that was the first glitchy pass. Obviously, the information that we're receiving isn't that glitchy because it's not very pleasant to listen to. So this is an example of the same information, but I've just kind of smoothed it out and stretched it a little bit. And it already sounds much, just performing that simple kind of stretching on it makes it sound much more like a sonification that might be distributed by a space organization. The final way that you can process this data, and there's many more ways as well. Basically, once you have information, you can map it to anything you like. If you're a visual thinker, just think about how you make a graph. You can map things to colors, you can map things to certain shapes. There's almost infinite possibilities. So that again links into the narrative kind of piece of the interest I have in information. There's a lot of control once you have a data set on what you can do with it. So this is the final sonification of that Voyager data set I'll play. It's all 3 plasma detectors linked up to an FM synthesizer. So yeah, so this is basically a very two-dimensional way of thinking about information. Is kind of like making these one-to-one mappings, taking a value, turning it into a sound or turning it into a visual. So for what I wanted to do and sort of working with these objects, I wanted to do something a bit more complex. So as a sort of a creative coder, I was thinking about it computationally. So I was thinking about my initial sonifications and visualizations as these almost like one-dimensional computational arrays. And an array is basically a structure you can store information within. So I was kind of really working with these kind of one-dimensional, two-dimensional arrays. I was interested in building something into like a very multi-layered set of information. So I had layers of data on top of each other that I could use to basically either present as one kind of massive data object, or I could present as something that took parameters of each layer and applied it to itself. So an example of this what I began to call the SuperLattice. And this is basically where I combine different data sets together to create a sort of a output that doesn't necessarily refer to any one of them, but incorporates all of them. So it's kind of like this 3-dimensional superstructure. So this is sort of an early kind of experiment with SuperLattices, where I took the genome of an adenovirus, which you can see here. So it's just a cropped section of that. And I converted that into an image. And then I started applying this adenovirus information onto satellite imagery. Particularly, I was interested in this kind of satellite imagery of really damaged places. So I kind of started seeking out those places. And that ended up being a project that I called Wounded Terrain. And I have a little video clip that I'll play in a minute. But basically, I really started to like these structures. And I mean, for me, I feel this is quite an evocative image because even though it is completely separate from this genome, you get a very clear stratification. So you can see that this genome has 4 layers, and each layer, if you know kind of information about DNA and stuff like that, you know each genome has a certain number of characters that are associated with it. So you can see here you've got G, C, A, and T. So it's going to be linked to those certain characters. So I found it really interesting just combining these multiple data sets and seeing what I got out. it kind of harkens back to the collisional aspects I was talking about earlier with the Nova installation, where I was taking all this information and sort of smashing it into itself and seeing what I got. But this was a bit more sort of, it's a bit more refined, and it's a bit more kind of aesthetically interesting and useful to me. So this is kind of the starting point for what I've been working with. This next clip is part of a multiple channel installation called Wounded Terrain. It has no sound, but it's 3 videos playing at the same time, and each video has different pieces of the environment that are really badly polluted or have been really badly destroyed physically by man-made activity. And what I've done is I've basically taken these satellite images and fed back information from the space, either if it's kind of chemical, what chemicals are polluting that landscape, or topological, like how that topology or topography has been altered. For example, one of the kind of satellite images I was using were these quarries in Italy, which have been mined for thousands and thousands of years, and the structure of the landscape is totally altered. So I used topological information to kind of alter that structure. And basically the idea is that these images are images, but they're also embodying the information of what's destroying them. So it's kind of like a feedback loop between the nature and man-made activity. And the images are being as distorted by the process as the man-made activity has distorted them from their kind of states of equilibrium. So it's a very slow installation. There's 6 videos in total. Each screen has 3, and one in the center has 1. So they basically are playing kind of in this kind of like slow loop that phases in and out of itself. So it's this kind of, these things are constantly breaking apart. You get glimpses of the initial landscape and then it breaks apart. And the way I presented it, I wasn't kind of explicit about the data I was using. I had quite didactic text that explained the locations. I explained the areas that were damaged and how these areas are polluted. And I hinted at some of the processes I was using and some of the data sets I was using, but I kind of left it up to the viewers to work out even just which place was which. Like I didn't sort of label the videos as it went through. So there's a couple of places that people could work out. Like there's some places in Canada that I worked with Lake St. Clair and high levels of algal blooms. And some people could work that out. And then for example, this is a glacier. And it's called Thwaites Glacier. And it's one of the fastest melting glaciers. And it's also one of the largest that I could kind of find information on. And so people could kind of get some information from the colors that obviously are just being manipulated from the original image. But it kind of was this process of almost making a kind of a visual puzzle where people had to spend time to actually work out what was happening and what the location was, to kind of get them to engage with environmental degradation just a little bit more, because they're spending a little bit more time just thinking about the process and trying to work out what's kind of unclear to them. I also kind of played around with some physical methods of distributing data in this way. So I created a couple of sort of kinetic installations where I would have data as a sound, and I'd have data represented on acetates, and these acetates would spin around on kind of makeshift mobiles, and sometimes it would align and you would get a full picture of this information I was trying to represent, but mostly it wouldn't align. And again, the idea was that the text gave you an idea of what the project was meant to be about. In this instance, I was working with something called a syzygy, which is basically alignment of 3 celestial objects. So the participant had information about that this was a syzygy, and it contained all the information they needed to sort of know to kind of recreate this astronomical occurrence in their mind. And all the information was there as well, but they had to sort of piece it together through various things like the acetates and the sound. So again, it became like this kind of like data puzzle where there's multiple layers of information, but you can't access them all at once. You have to access them separately, and over time, it was this kind of like development of almost, I think the goal of this piece was to almost use the viewer as a sort of machine. So give them access to information and then see how they compile it in their mind based on this text. So again, it's trying to play with that idea of giving people information and providing a narrative and seeing how that narrative can instruct how someone engages with a thing. Like this is a, this is an installation, but it's also an object, and see how I can sway that decision to interact and engage based on the text I give. Another really important kind of thing for me is translation. I'm going to go through it in a bit and just show you a bunch of images from the kind of the development process of kind of coming up with my more current work. But a really interesting idea for me was translation of audio and translating audio into image and then using that as kind of a source for machine learning. So these are all sections, 1 second sections of a piece of music made by Max Matthews, who was sort of a computer music pioneer. And I believe this is the first piece of synthesized voice. So the audio I used initially was Daisy Bell, which I probably have I think I have a link to it in my audio, which I'll play in a bit. I certainly have a link of the machine learning processed ones. But basically I wanted to find a really easy way for me to get into machine learning. And a lot of the machine learning in terms of audio was a little bit out of my reach. There's more documentation that I could kind of get my head around, at least around machine learning for image. So I started encoding 1 second snippets of pieces of music. So I would basically break down a piece of music into these 1 second snippets. So each 1 second snippet is converted into an image, which has 44,100 pixels, kind of using the same method I was talking about earlier, or the reverse method of converting the information from the Voyager probe into a sound. This is taking the sound and converting that sound into an image. So it's kind of just a reverse of that process. So you get a grayscale image, and each one represents a second of audio from that piece of music. And then basically I loaded this into a machine learning model and then applied the same information to itself. So basically I was taking Daisy Bell and I was reapplying Daisy Bell to itself. And the machine learning model is looking for similarities between the two image sets and then trying to output something that is more similar to itself. So basically I'm trying to get the homogeneousness of two versions of Daisy Bell combined together. So this is some of the corpus, the initial images I put in. These are some of the outputs. The process was a little glitchy. I'm not like super expert at machine learning, and definitely there was a degradation in the image, which I wasn't particularly averse to because I quite like glitch aesthetics anyway. But listening to some sounds, yeah, so this is a short example of some of the sounds that were output from that process. I'm not sure I have the Daisy Bell accessible right now, but you can find it online. So you can hear some of the kind of harmonics, and I mean, if you're maybe not over the network, but you can hear some of the initial harmonics from this piece of music, but they're really basically distorted into this electronic cry. Another pass of that information resulted in something like this, and this is just a 1 second output. So you can hear sort of like the initial, you actually can hear elements. So this kind of translation was really of interest to me, and it kind of developed from earlier text experiments where basically I was taking images and converting those into text files just with the idea of storing quite complex information in the simplest format I could really imagine. This was a piece based around Harry Potter called You Have Your Mother's Eyes. Lots of eyes, if you can't see. And then also like with the acetate work I was doing, like combining these multiple things over themselves. So I, just take the metadata from an image and then map that metadata into, the key points of the image itself. So here it just says pigeon, and then it maps that over images of pigeons. So I just took the metadata and it basically finds the kind of the content of the image and tries to recreate that in text and then applies it to itself. Translation was also really important in machines. So I was using these machines to draw. And what I really like about machine drawing is that it's kind of like a seismograph. And that's also been something that's interesting to me of late, is that just information gathered scientifically had, in terms of like seismic information or even astronomy stuff, it's so much clearer because of COVID-19 and much less pollution. So these kind of inherent wobbles and things that kind of alter information that people have to build algorithms to remove are kind of much less at the moment. So the information that can be sourced in certain areas of science is a lot more accessible. But I'm interested in applying the glitches and the errors. So when I kind of put my machines out, I have drawing machines that I've made and they repurpose and redraw images. So this is a chromosome, if you can make it out. But basically there's a lot of stuff going on in the surrounding area that could cause fluctuations to it. So the goal of the machine is to basically do a dithered dot drawing of whatever image I put in. But obviously based on things like vibrations in the area, or if the elevation of the page is slightly too high, you get these fluctuations. So you can see here, like there's different kind of dot patterns here. You actually have lines because the paper was too high. Zooming in, you can see kind of like some of the detail of that. And I really like these pieces because to me, it incorporated not just the sort of the image. And I love digital imagery, but I do find there's sometimes for me a coldness to it. And then outputting something for a physical process like a drawing machine or other physical processes, like I do a lot of stuff where I convert stuff into grooves, which can be laser cut and create these mechanical records that you can play back. So for me, the kind of, even though they're not perfect reproductions, the errors that are introduced by this kind of imperfect system are really interesting, and they create something that's new and exciting to me. Like I wasn't expecting this pen mechanical drawing to turn out how it did. And it's one of my favorite things because it's wrong. So that's been super interesting to me. Again, I think I was talking about some of these kind of like conversions from information into physical objects. So this was a project a year or so ago in upstate New York, where I basically built a bunch of records that had astronomical data cut into them. So this is a sonification of Saturns Rings, and I thought it'd be quite poetic to create a record out of Saturn's rings, because a really common thing people say is, the rings of Saturn look like a record. In fact, they're concentric rings, so it wouldn't play like a record. They'd be locked grooves. I made a record out of them anyway. But yeah, it was a poetic notion. Again, this conversion of drawing. The only thing I really have for my studio is just a bunch of acetates. And so basically one of the things I've been doing is just taking images that I had and just, lots of bits of plastic and recombining them in different ways. So kind of taking visual information and creating these clusters of fractals or points, or even like, maybe it's invisible, but these are dots. The idea is to create moire patterns and just see how things act when I combine, or diagrammatic stuff. So this is basically, this only really works as a shadow, but it's very thin lines of diagrammatic stuff, kind of inspired by some of the stuff that was sent on chips into space. Like, I don't know if you're familiar with I can't remember the specific kind of space mission, but Andy Warhol and Robert Rauschenberg and a bunch of people had little like tiny images kind of on a chip that was sent into space quite early on. So it's kind of inspired by those very simple diagrams. This is kind of a more up close look of some of the grooves that I cut to create these kind of records. And this is a layout of an installation I did at the Factory Media Center last year. And then basically kind of the recent stuff I've been doing has been really limited by quarantine. I've lost a lot of access to some of the tools that I normally use. But I've been getting really into kind of sensing my space and using objects that are really accessible, like just cameras, to get into creating these makeshift 3D models. So I've been using makeshift photogrammetry apps to basically track walks I do. This is a plant. It's wrong. It's not like a perfect 3D model of a plant. I'm kind of emphasizing these errors. And so these are created through my iPod camera and through Xbox Connects. So basically doing kind of combining depth scans with things like that. And I made a really quick project recently just for fun, really, of a couple of sketches. I called it inbound outbound. So basically it's just playing with 2D images, converting them into 3D, and basically just sensing my space and feeding that back into software, and then kind of creating this kind of performative audiovisual work just through the space that I'm living in. And that's pretty much really the stuff I wanted to show. It feels quite brief, but I think I've been talking for a while. Basically, the development that I'm going to be doing over the coming months involves kind of taking this stuff a little further with the machine learning part, partly because I have taken quite a while. It's taken me quite a long time to actually get to any sort of level of machine learning, and I'm not great at it. So it's kind of been amping up, and as I grow in understanding, that gets easier. So the idea of using machine learning models to create new sensory media, either if it is, I would like to do something that's audiovisual based and real time is kind of a goal there. And then I also want to develop the kind of the framework I'm thinking about with narrative and data, to talk to schools about actually kind of like data protection. Because I think a lot of people, especially young people who kind of are natively interacting with phones, don't necessarily think about how information is being shared, how their information can be used as a negative tool against them, how they can actually protect themselves from this stuff. And even if it's a very basic kind of just data literacy course, I think thinking about some of these concepts can help them in a number of ways for protecting their data, and also how they kind of digest information and news that they're given. Because I think that's something that's really challenging to do in this day and age, is that there's so much content that's really hard to break it down. And quite often, people look at one source, they don't go to multiple news outlets, and they don't think about these inherent biases that are part of systems. And part of that kind of training would just to be presenting almost like examples of machine learning models that do have biases built in. Like one of the things I've been looking at is things like ImageNet Roulette by Trevor Paglen and his collaborator, where they kind of reveal I think a lot of people did this, where they took a photo and saw the metadata that's tagged from AI that's linked to them, and a lot of kind of racist and sexist bias was attached to these. And these were things that were named through Amazon's Mechanical Turk by people initially, and then put into a system, and then it just propagated because this data set was shared with other people, other corporations who didn't necessarily know there was a negative bias, but it just kept kind of going and going. And then took someone just to reveal the text that was associated with images for it to kind of be acknowledged, I guess. And then after that, about 600,000 images were removed or renamed. So it's kind of just having this kind of basic data literacy and understanding of how things are shaped, I think would be really useful. So I'm going to unshare my screen and take some questions if anyone has any questions.
That looks like there's a question in the chat. Do you want me to read it out?
Sure. Yeah.
So what is the coding programs you used for the project in the first half of your presentation, like for Nova?
Okay. Yeah, so I work in kind of a modular way. And basically I kind of bring loads of things together. So Nova was actually built with a couple of different programs. Things that I kind of were my go-tos a lot, and I still use quite consistently. I use Max MSP and Pure Data for audio signal processing almost kind of exclusively. I don't really code very much audio in C. So yeah, those are my go-tos. They're kind of graphical programming languages. So you have these kind of objects that you connect to each other. The learning curve can be steep, but it's easier of it than kind of pure coding. So that's something that I go to a lot, because I enjoy working in those environments, and I feel I can get something quickly that also can sometimes sound good. Visually, I used to work a lot with the processing language. I also worked with Max MSP's jitter library quite a bit. But as I kind of progressed in, I wasn't someone that's particularly good at coding. I still don't consider myself a good coder. I think of coding more as like a tool, and I learn the things that I need to learn to achieve the projects I want to. And obviously over time, I've been doing it for about 7 years now. You improve and you learn things, and you have code that you did before that you can kind of copy and paste into things. And you kind of, even if I'm confused about something, I can now read code and have a fairly high literacy. So the language I used to use was processing, and I'd recommend that to anyone getting started. Processing or P5JS, and I think there's a workshop coming up at Interaxis in a couple of weeks.
It already happened.
Oh, it already happened. Okay.
But it's okay.
But I totally recommend those languages because they're designed for artists. So there's a lot of stuff that's actually like made simplified. So it's easier to access certain functions. So I actually still go to processing quite regularly to sketch ideas out. And then I would use things like Java or C sometimes. Quite often Python. I started learning Python about 6 months ago. And kind of I've begun incorporating Python quite a bit because I found that to be really useful to develop utilities. I'm still not great at it, but it's been useful, especially for the machine learning stuff. It's been quite helpful.
If you'd like to ask a question, feel free to unmute yourself. Oh, there's another one. Do you want me to read it?
Sure.
Okay. Shani from Critical Distance, hi Shani, asks, I'm wondering about how machine learning intersects with what's happening in AI, as in, is machine learning distinct from AI? And have you worked in any kind of dialogic capacity with machines or AIs where there is a qualitative response from the machine that might be unpredictable? Good question, Shani.
Yeah, that's a great question. It's sort of hard for me to fully answer because I don't feel like I can really speak to a lot of the deeper stuff around machine learning. I think I'm very much still an outside viewer, and kind of I'm getting in there and trying to learn about it. From my knowledge, I think like I use machine learning and AI interchangeably. I'm not sure if that is correct or not. Like I know some people that could certainly correct me. If my friend Miles is still watching, he could probably comment if there's a difference. To what I know, it's interchangeable. And yes, I'm really interested in the errors that kind of occur when things go wrong. So there's a book that I think I was pointing out yesterday. It's called "I Look Like a Thing and You Look Like a Thing and I Love You," and it's sort of a really cute book around machine learning kind of errors and things around that, where machines kind of I think a good example would be, you know, when there was image recognition, and it would kind of, you'd give it an image and it would tell you what was in the image. And someone used the example of kind of like 2 eggs on a plate, and it was something like 2 boiled eggs next to a plate. And it's kind of like, it's got everything in the image, but it's slightly wrong. Like it's not thinking of it as a meal, it's thinking of it as these separate items. So I definitely think there's a lot of, you know, there's a lot of error that happens, and it's obviously also related to the system and how it's trained by people.
Thank you. Thanks.
Thanks, Jenny.
Thanks for the question.
Are there any other questions? Feel free to unmute. I was wondering about your interest in astronomy, Dan, and how that started. Seems to be kind of thread through all your work.
Yeah, I mean, I think as a child, I wanted to either be an astronomer or like a space person or a dinosaur. And one of those was definitely not an ability I had. So I got really into space. I'm not sort of someone that was very good at school. Like I wasn't good at maths. I wasn't good at science. So like this came later. I didn't really know that I could get into working with astronomers and accessing data until I was like older. And then I was like, oh, actually like this stuff isn't as complicated if you can find a fun way of applying it. And that was really how I got into coding, because I was like, yeah, I want to create some images. I want to see if I can access this data set from NASA and make something cool with it. So that was basically how I started. And then I was just like, wow, there's so much amazing open source information from NASA. There's like tons and tons of really great, like I think when people think about space exploration, think about NASA, but there's millions of schools and places that have very specific data collection agencies. And sometimes that can get kind of incorporated into the work that NASA does. But if you just spend a bit of time looking online, you can find tons of open source data that you can access. Like there's probably like 20 or 30 places that I've sourced data from just for mapping the sun. And that's probably just scratching the surface of actually all the people that are actually collecting this data. So I think it's super exciting. As I learn more about it, I think of more things to do with it. And it kind of informs me about the solar system, which is something that's great for me because I always wanted to, you know, be an astronomer. So maybe one day I'll be able to transition and be not like an artist/scientist, but be a scientist/artist. Maybe.
Yeah, maybe. And there's also so much unknown with the solar system and with space, right? So it goes back to your interest in errors and abstraction and kind of chance as well. So wait, two new questions. Niles asks, I was wondering if you have any recommendations for starting out with machine learning and music, or any frameworks to check out.
Yeah, for sure. So the first thing I basically tried was I basically, when I want to do something, I think I first look to see if there's anything that's like proprietarily available, and that's also free that I can access. To kind of just get a basic idea. So the first thing I did with the machine learning stuff, because I knew it was going to take a while before I could even really program anything, was I looked online and I found this thing called playform.io, which I think was in beta at the time, and now it's kind of become more publicly available. And basically that allows you to upload data sets, so a training set, and then a set that you want to kind of map it to, and then you can work with that. So I looked at that, and then they also have their API available. So you can, once you kind of get to grips with that, you can access some of the tools they're learning. And then there's a really good, I don't know how to say the word, but I think it's cadenza, cadence course called TensorFlow and Artists. And I can't remember who the guy teaching it is, but it's a really great introduction to the machine learning kind of framework of TensorFlow and how to use that as an artist. And it's not aimed at someone who's like a fantastic coder. Like you can get into it from the ground up, which is great. So I'd recommend Playform.io and Cadenza course, which is also free.
What's the first one? Playful?
Playform. So I'll write it.
Okay.
And let's see if I can get everyone. And there's an artist who is really great to check out. which I'm also writing down because I'll say his name wrong. I think it's called Mario Klingerman. But his work's really fantastic. I think there was another question from Miles Forrester about poetry.
Yeah.
Yeah,
So
poetry in relation to my work.
it's a great question. So Miles is interested in how you, so how, Dan, do you think about poetry in relation to your work? Is it a metaphor for the relationship between the input and output, or is there another part of the craft in this that you feel is poetic?
I actually, yeah, I'm glad that, someone asked that, I guess, because like for me, the initial way I got into coding was calling my blog Code Poetry. And it basically, the idea is I likened code in my mind to like writing a Zen or haiku kind of poem form. So really putting constraints around my code writing in terms of time and kind of brevity to kind of, I think if I had set out to kind of spend 8 hours coding a day, I just wouldn't have done it. So these 30-minute segments where I would make a thing really helped me do that. And I think that not necessarily the idea of poetry has influenced everything I've done, but this idea, I think quite romantically. So I think a lot about poetic of stuff. So for example, like I thought it was very poetic to make a vinyl disc that had the sonification of the rings of Saturn cut into it, because it seems like this kind of direct correlation that people can understand. And I think I try and use poetry. I'm interested in kind of educating people about science and technology as well, because I'm not someone that came natively to it. It was hard. And I think the hardest thing was I was just scared to get involved. Like I didn't think about if I could actually do it or not. I was like, oh, I'm just too stupid to do this. So it took a while, and I had to be older before I actually started just trying stuff because I was too nervous before. So for me, poetry is a really nice way of creating an analogy for people that they can kind of get in on. And if it's a creative project, they can find out about the science in as much as they want to. They can see it as like a nice art installation that looks pretty, or they can kind of find out a bit more. And I've written a couple of space-inspired poetry books. I did a residency about 2 years ago, just around the time when I made the Saturn disk. And I basically made a bunch of kind of like these sonifications of each planet, which I made into radio shows, and then I read poetry out, which I'd written about each planet that was kind of linked to the characteristics of each planet. So I think poetry is really important to me. It's not necessarily always that featured in my work, but a lot of the work I've been doing lately, the groundwork of that was inspired by Christian Bock, who's sort of a Canadian experimental poet, who did things like encoding his poetry into bacteria that would then kind of last. The idea is the bacteria will last beyond the apocalypse of humans, but who knows?
So one more technical question. So how do you find the balance between your project's concept, like what you wish to realize, and the skills you have to implement it? So to what extent do you adjust your project based on the technical limitations?
For me, like I'm always kind of, I think I work in like I said earlier about the software I use, I also work in a quite modular way. I often like have maybe a project or a couple of projects at the back of my mind, but I'm maybe not setting out to work on those projects fully. So I'll do things like I'll be doing little bits of code or making little sketches just to kind of get an idea of how things come together. So then when I actually come around to putting together a project, it's more like almost like video editing, because I've got this piece of code and I know how to put these things into it to make the output I want. So there's definitely a limitation by the technology and the skill of the technology I have at the time, because sometimes in my mind I have really amazing ideas and I can't get to that level based on the equipment I have or the skills I have. I think something that's really important with some of the work I want to do is branching out and collaborating. I haven't done that many. I've worked as a collaborator where I kind of do the back end and the code and stuff, but I haven't worked on projects myself where I've given that ability to collaborate to people. I'd love to do that and kind of jump in the deep end of actually collaborating and doing things, because I think you can create things that are greater than the sum of their parts if you start working with people and you have a good relationship between that.
That kind of leads us to,
I don't know if that answers the question.
your next, I mean, with this new limitation in terms of space, what's your new project gonna, like, what are you imagining that it will lead to?
Yeah, I mean, I'd like to see how it goes, because a lot of bandwidth was taken up by like the initial quarantine stuff, and I wasn't really working for the first like 2 weeks of being sort of self-isolated, and now it's better. The last kind of week and a half I've been making again, but I'd like to just think about, I really like publications and I really like books. I'd like to find a way of kind of consolidating some of the stuff I've been doing it into actually like physical book. And I've been working with a cellist, and I'd like to actually release that as an album. So I think kind of refining some projects I have on the go into like actually published material that I share with others, because it's sometimes there's like these side projects that you never do anything with, and it takes years to put them out. And I want to do that.
That sounds great. Thanks, Dan. Is there any other questions before we wrap up? This was so...
There's also, I just wanted to point out, Stephen Boyd has given a couple of good tools for the people that were looking at machine learning and AI stuff. He's posted it to the group, but he says Runway ML and ML5.js are friendly on-ramps for incorporating AI/machine learning into arts and audio projects too. So for anyone, I'll take a look at those and try those out. They look great.
Well, I think that's it. Thank you so much, Dan.
Yeah, thanks for having me. Thanks for joining the talk, everyone. It's been a blast.
Thank you, Dan. It was great.
Oh, thank you, Nava. Thanks for coming along. How are you?
I'm doing great. I just wrote you. So I think glitch aesthetic is beautifully poetic.
Thank you.